Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of three mathematics questions that were asked in recently held JEE Advanced 2025 Paper 1 exam. This is the first question of this video. This question is based on the topic of three-dimensional geometry. It says, let L1 be the line of intersection of the planes given by the equations 2x plus 3y plus z equal to 4 and x plus 2y plus z equal to 5. Let L2 be the line passing through the point P 2, minus 1, 3 and parallel to L1. Let M denote the plane given by the equation 2x plus y minus 2z equal to 6. Suppose that the line L2 meets the plane M at the point Q. Let R be the foot of the perpendicular drawn from P to the plane M. Then which of the following statements is R true? The first option is the length of the line segment PQ is 9 root 3. The second option is the length of the line segment QR is 15. The third option is the area of triangle PQR is 3 upon 2 into square root of 234, and the last option is the acute angle between the line segments PQ and PR is cos inverse of 1 upon 2 root 3. Now students, we start solving this question. Now students, this is a multiple option correct question, and as per the options, we have to find the length of PQ, length of QR, area of triangle PQR, and the acute angle between the line segments PQ and PR. And in this question, we have been given a line L1, that is the line of intersection of two planes. Now the equation of the first plane is 2x plus 3y plus z equal to 4. And the equation of the second plane is x plus 2y plus z equal to 5. Now students, since L1 is the line of intersection of these planes, so it must be contained in both of these planes. So I can say that line L1 will be perpendicular to the normals of both of these planes. So that means the vector along the line L1 will be given by 2i plus 3j plus k cross I plus 2j plus k. That means it will be given by the determinant of, in the first row we have ijk, in the second row we have 2, 3, 1, and in the third row we have 1, 2, 1. Now students, let's find the value of this determinant. It comes as I into inside the bracket 1, then minus j into inside the bracket 1, plus k into inside the bracket it is 4 minus 3 again 1. So this is I minus j plus k. Or I can say that the direction ratios of the line L1 are 1 is to minus 1 is to 1. Now students, there is no need to find the equation of the line L1. We have to just find the direction ratios of the line L1, because now we will find the equation of the line L2, which is parallel to the line L1 and passing through the point P 2, minus 1, 3. Now students, we move further. Now students, I can easily write the equation of the line L2 as x minus 2 divided upon 1 equal to y plus 1 whole divided upon minus 1 equal to z minus 3 whole divided upon 1. If I put it equal to lambda, where lambda is a real number, then I get the general coordinates of any point lying on the line L2 as lambda plus 2, comma, minus lambda minus 1, comma, lambda plus 3. Now students, it is given that the line L2 is intersecting a plane M at the point Q, and the equation of plane M is given as 2x plus y minus 2z equal to 6. Now to get the coordinates of the point Q, I will put the general coordinates of any point lying on the line L2 in the equation of the plane M. So now it becomes 2 times inside the bracket lambda plus 2, then minus lambda minus 1, and then minus 2 times inside the bracket lambda plus 3 equal to 6. Now students, when we solve this equation, we get minus lambda plus 3 minus 6 equal to 6. And from here we get the value of lambda as minus 9. Now, when I put this value of lambda in the general coordinates of any point lying on the line L2, then I get the coordinates of the point Q as minus 7, comma 8, comma minus 6. Now students, we move further. Now students, it is further saying in the question that a perpendicular from the point P is drawn onto the plane M, and the foot of this perpendicular is the point R. So now we have to find the coordinates of the point R. But before this, we need to find the equation of the line PR. So now I can write the equation of line PR as, now students, the line PR is passing through the point P. So I will use the coordinates of the point P in writing the equation of line PR, and the direction ratios of this line PR will be same as the direction ratios of the normal to the plane M. So that means the equation of line PR becomes x minus 2 divided upon 2 equal to y plus 1 divided upon 1 equal to z minus 3 divided upon minus 2. Right? Now students, I am putting it equal to mu, where mu is a real number. So from here, we can write the general coordinates of any point lying on the line PR as 2 mu plus 2, comma, mu minus 1, comma, minus 2 mu plus 3. Now students, to find the coordinates of the point R, I will put the general coordinates of any point lying on the line PR in the equation of the plane M. And equation of plane M is two x plus y minus 2z equal to 6. So now when we put the general coordinates in terms of mu in the equation of plane M, then it becomes 2 times inside the bracket 2 mu plus 2 plus mu minus 1 minus 2 times inside the bracket minus 2 mu plus 3 equal to 6. Now it becomes 4 mu plus 4 plus mu minus 1 plus 4 mu minus 6 equal to 6. From here we get 9 mu equal to 9, or mu equal to 1. So students, when I put the value of mu as 1 in the general coordinates of any point lying on the line PR, then I get the coordinates of the point R as 4, 0, 1. Now students, we move further. Now students, we have the coordinates of P as 2, -1, 3. The coordinates of point Q as -7, 8, -6. And the coordinates of the point R as 4, 0, 1. Now from here, I can easily find the value of PQ with the help of distance formula, and it becomes square root of 9 square, that is 81, plus 9 square, again 81, and then plus 81 again. So it becomes 9 into square root of 3. So that means option A is correct. Now students, we find the value of QR. Again, we will use the distance formula. So the value of QR becomes square root of 11 square, that is 121, plus minus 8 square, which is 64, plus 7 square, which is 49. And now this value becomes equal to square root of 234. Now students, this is not equal to 15. So that means option B is not correct. Now students, we have to find the area of triangle PQR. We know that both points Q and R, they lie on the same plane M. And since PR is perpendicular to the plane M, so I can say that triangle PQR is right angled triangle. So hence area of triangle PQR will be equal to 1 upon 2 into PR into QR. Now students, we find the length of PR again by using distance formula. It becomes square root of 2 square, which is 4, plus 1 square, which is 1, and plus minus 2 square, which is 4. So this becomes square root of 9, and this is just 3. Now students, the area of triangle PQR becomes 1 upon 2 into 3 into square root of 234. So this is nothing but 3 upon 2 into square root of 234. So hence option C is also correct. Now students, we move further. Now students, we have to find the acute angle between the line segments PQ and PR. Let's call this acute angle as theta. Now I will find the value of theta in two different ways. The first method is, we know that triangle PQR is right angled at the point R. So by using trigonometry, I can say that cos theta is equal to PR upon PQ. Now PR is 3 and PQ is 9 root 3. So this becomes 1 upon 3 root 3. So from here I get the value of theta as cos inverse of 1 upon 3 root 3. So that means option D is not correct. Now students, this is the second method, and in the second method I am using the concept of vectors. Now cos theta can be written as mod of PQ vector dot PR vector whole divided upon mod of PQ into mod of PR. Now students, vector PQ is equal to minus 9i plus 9j minus 9k, and vector PR is equal to 2i plus j minus 2k. So that means cos theta is equal to mod of minus 18 plus 9 plus 18 whole divided upon mod PQ is 9 root 3 and mod of PR is 3. So this becomes equal to 9 upon 9 root 3 into 3. Now students, this is finally 1 upon 3 root 3. So that means theta is equal to cos inverse of 1 upon 3 root 3. So we finally conclude that option A and C are correct. Now students, we move towards the next question. Now students, this is the next question. This question is based on the topic of functions. It says, let capital N denote the set of all natural numbers and Z denote the set of all integers. Consider the functions f n to z and g z to n defined by f of n equal to n plus 1 whole divided by 2 if n is odd and 4 minus n whole divided by 2 if n is even, and g of n equal to 3 plus 2n if n is greater than or equal to 0 and minus 2n if n is less than 0. Define g of f of n equal to g of f of n for all n belonging to capital N, and f of g of n equal to f of g of n for all n belonging to capital Z. Then which of the following statements are true? The first option is g of f is not 1 1 and g of f is not on 2. The second option is f of g is not 1 1 but f of g is on 2. The third option is g is 1 1 and g is on 2. And the last option is f is not 1 1 but f is on 2. Now students, basically in this question, we have to check the 1 1 and on 2 nature of 4 functions. And they are f, g, f of g and g of f. Now let's move towards the solution of this question. Now students, we have been given two functions f and g. The function f is defined from n to z and f of n is given as n plus 1 whole divided by 2 when n is odd, and it is equal to 4 minus n whole divided by 2 when n is even. Now students, let's check the 1 1 and onto nature of the function f of n. Now when n is odd, I can put n equal to 2m plus 1, where m is any non-negative integer. That means n is any integer greater than or equal to 0. Now, when we consider this case, then the value of f of n becomes equal to 2m plus 1 whole divided by 2, which is equal to m plus 1. So that means the set of all possible values of f of n in this case is going to be 1, 2, 3, and so on. That means it is going to be the set of all positive integers. Right? Now students, we consider the second case when n is even. Now when n is even, I can put n equal to 2k, where k is any natural number. That means k is any integer greater than or equal to 1. Now when we put n equal to 2k, then the value of f of n becomes equal to 4 minus 2k whole divided by 2, or 2 minus k. Now the set of all possible values of f of n in this case is going to be, when I put k as 1, the value becomes 1. When I put k as 2, it becomes 0. When I put k as 3, it becomes minus 1. So that means it will contain all negative integers and 0 and 1, right? Now students, we move further. Now students, if I take the union of both of these sets, then I get the range of the function f of n as the set of all integers. So that means range of this function is same as its codomain. So clearly f of n is onto. And students, we have also noticed from the previous discussion that there are two different values of n for which f of n is equal to 1, and they are 1 and 2. That means the value of f of 1 is same as f of 2 and both are equal to 1. So this implies that f of n is many 1. That means f is not 1 1 but onto. So hence option D is the correct one. Now students, we discussed the function g of n. Now g is a function that is defined from z to n, and it is given as g of n equal to 3 plus 2n when n is greater than or equal to 0, and this is minus 2n when n is less than 0. Now students, we will discuss the 1 1 and onto nature of the function g of n. Now students, when we take n as any integer greater than or equal to 0, then the value of g of n is 2n plus 3, which is clearly a positive odd integer. So the set of all possible values of g of n in this particular case will contain the elements 3, 5, 7 and so on. That means this is the set of all odd integers greater than 1. Now similarly, when we take n as any integer less than 0, then the value of g of n is minus 2n, which is clearly a positive even integer. So I can say that the set of all possible values of g of n in this particular case will contain the elements 2, 4, 6 and so on. So this is the set of all positive even integers. Now students, from here I can find the range of g of n by taking the union of both of these sets, and this comes as n minus 1. So clearly the range of this function is smaller than its codomain. So from here we conclude that g is an into function. Now students, when we take n as any integer greater than or equal to 0 and start putting the values of n in g of n, then every time we get a different odd number. Similarly, when we take n as any integer less than 0 and start putting the values of n in g of n, then every time we get a different even number. So this means there are no two different values of n for which g of n is same. So hence from here we conclude that g is 1 1. So that means g is 1 1 but into. So this means option C is not correct. Now students, we move towards the remaining two functions, that is f of g and g of f. Now we know that g is defined from z to n and f is defined from n to z. So clearly the function f of g will be defined from z to z, and the function g of f will be defined from n to n. Now students, we move further. Now students, we find the function f of g of n, which is actually f of gn, and it can be found in this way. Now when n is greater than or equal to 0, then g of n is 2n plus 3, which is clearly a positive odd number. Now students, this value 2n plus 3, we will have to put as n in the first branch of f of n. That means now the expression will become 2n plus 3 plus 1 whole divided by 2. And similarly, when n is less than 0, then g of n is minus 2n, which is clearly a positive even number. Now this value minus 2n we will have to put as n in the second branch of f of n. So now the expression becomes 4 minus inside the bracket minus 2n whole divided by 2. So students, the function f of gn becomes n plus 2 when n is greater than or equal to 0, and again n plus 2 when n is less than 0. So that means it is simply n plus 2 where n belongs to z. Now students, let's discuss the injectivity of the function f of g. Now I am considering two different inputs n1 and n2, both belonging to z. Now if f of g of n1 is equal to f of g of n2, then this implies that n1 plus 2 will be equal to n2 plus 2. And this clearly means n1 is equal to n2. So this means there are no two different values of n for which the function f of g will become same. Hence, the function f of g is 1, 1. Now students, clearly the option B is incorrect. But still you can check the onto nature of the function f of g. Now we move further. Now students, let's discuss the onto nature of the function f of g of n. For this purpose, I am putting it equal to y. That means y equal to n plus 2. So from here we get n equal to y minus 2. Now whenever y is an integer, then the value of n is also an integer. This means that for every value of y belonging to the codomain of the function, there always exists its pre-image lying in the domain of the function. So this means the function f of g is onto. Now students, I have already discussed that option B is not correct because f of g is 1, 1 and onto. Now students, we move towards the last function, that is g of f. Now we know that this function is defined from n to n. Now let's find the function g of f of n. Now students, when n is a odd natural number, then the value of f of n is n plus 1 whole divided by 2. Now since n is a odd number, so n plus 1 will be even, and when even number is divided by 2, clearly we are going to get a positive integer. Fine. Now students, the value n plus 1 whole divided by 2 will be put as an input in the first branch of the function g of n. So now the expression will become 2 times of n plus 1 whole divided by 2 plus 3. Right? Now students, when we take n as an even number, we cannot find the function g of f of n directly. For this, we will have to make three cases. Now the first case is when n is equal to 2. Now when n is equal to 2, then the value of f of 2 will be 1, right? Because it will be evaluated from the expression 4 minus n whole divided by 2. Fine. So that means the value f of 2 is 1. Now this value 1 will be taken as an input in the function g of n, and it will go to its first branch. So now the value 1 we will have to put in the expression 2n plus 3. So now the value comes as 5. Similarly, when you take n as 4, then f of 4 becomes 0. Now this value 0, you have to put in 2n plus 3. So now the final answer comes as 3. And now students, lastly, we will take n as an even number greater than 4. And in this situation, the value of f of n will be 4 minus n whole divided by 2. And now this expression will go as an input in the function g of n. And now it will be minus 2 times inside the bracket 4 minus n whole divided by 2. Right? Now students, we move further and discuss the 1 and onto nature of the function g of f. Now students, the function g of f of n can finally be written as n plus 4 when n is an odd natural number. It is equal to 5 when n is equal to 2. It is 3 when n is equal to 4. And it is n minus 4 when n is an even natural number greater than 4. Right? Now students, when we put n equal to 1 in the function g of f, then we get the value of g of f of 1 equal to 5. And we already have g of f of 2 equal to 5. So this means g of f of 1 is equal to g of f of 2. Hence the function g of f is many 1. Or we can say that g of f is not 1. Now students, to discuss the onto nature of the function g of f, we need to find its range. And to find the range, we will have to consider different cases. Now when n is an odd natural number, then we get the outputs of the function g of f as the set containing the elements 5, 7, 9 and so on. That means we get all odd natural numbers greater than 3. And we get the output as 3 when we put n equal to 4. And finally, when we put n as an even natural number greater than 4, then we get the set of outputs as the set of all even natural numbers, that is 2, 4, 6, 8, 10 and so on. So that means if I take the union of all of these sets, then the range of g of f becomes the set containing all the natural numbers except 1, that is 2, 3, 4, 5, 6 and so on. So the range is n minus 1. Now students, clearly the range of this function is smaller than its codomain. Hence, we can say that the function g of f is into. That means it is not onto. So finally, we conclude that option A and D are correct. Now students, we move towards the next question. Now students, this is the last question of this video. This question is based on the topic of complex numbers. It says, let capital R denote the set of all real numbers. Let Z1 equal to 1 plus 2 iota and Z2 equal to 3 iota be two complex numbers where iota is equal to square root of minus 1. Let S equal to the set containing the ordered pairs x, y which belong to R cross R such that mod of x plus iota y minus z1 is equal to 2 times of mod of x plus iota y minus z2. Then which of the following statements are true? The first option is S is a circle with center minus 1 upon 3 comma 10 by 3. Second option is S is a circle with center 1 by 3 comma 8 by 3. And the third option is S is a circle with radius root 2 upon 3. And last option is S is a circle with radius 2 root 2 upon 3. Now students, this is a multiple option correct question. Now let's solve it. Now students, in this question, we have been given two complex numbers Z1 and Z2, where Z1 is equal to 1 plus 2 iota and Z2 is equal to 3 iota. And the set S contains the ordered pairs x, y, where both x and y are real numbers, and mod of x plus iota y minus Z1 is equal to 2 times mod of x plus iota y minus z2. Now students, basically in this question, we have to find the locus for the point x, y. And for this purpose, I will use this equation and put the values of z1 and z2 in this equation. Now it becomes mod of x minus 1 plus iota times y minus 2. I have separated real and imaginary parts, and this is equal to 2 times of mod of x plus iota times y minus 3. Now students, we know that mod of a plus iota b is equal to square root of a square plus b square. So from this formula, it becomes square root of x minus 1 whole square plus y minus 2 whole square on the left hand side, and on the right hand side it becomes 2 into square root of x square plus y minus 3 whole square. Now square both sides of this equation. Now it becomes x minus 1 whole square plus y minus 2 whole square equal to 4 times inside the bracket x square plus y minus 3 whole square. Now students, we move further. Now students, this equation can further be written as x square plus y square minus 2x minus 4y plus 5 equal to 4x square plus 4y square minus 24y plus 36. Now it becomes 3x square plus 3y square plus 2x minus 20y plus 31 equal to 0. Now just divide this equation throughout by 3. So it becomes x square plus y square plus 2 upon 3 into x minus 20 upon 3 into y plus 31 upon 3. equal to 0. Now students, clearly this is an equation of a circle with center at minus 1 upon 3 comma 10 upon 3, and radius of this circle is square root of 1 upon 9 plus 100 upon 9 minus 31 upon 3, and this further becomes equal to square root of, in the denominator we have 9 and in the numerator it is 101 minus 93. So it becomes square root of 8 by 9, which is nothing but 2 root 2 divided by 3. So that means option A and D are correct. S is a circle with center at minus 1 upon 3 comma 10 by 3, and S is a circle with radius 2 root 2 divided by 3. Now students, I have created two separate playlists of paper 1 and paper 2 for JEE Advanced 2025 maths paper solutions. So you can go to the playlist section of my channel and watch all the videos. So keep watching my videos and enhance your knowledge of mathematics. Thanks.